Yeah, so I wanted to try solving this problem. Um, it's today's daily question. So, given a triangle array, return the minimum path from the top to the bottom. So it looks like we're given a 2D array, but each row it grows in size by one. So it's a triangle essentially. And we're starting from the top. We have to return the path that has the least sum. And so the first thing that comes to mind is that BFS returns the shortest path in a traversal problem. But BFS only works when we're dealing with unweighted. And here it's technically weighted because from each node has a certain weight to it. And so um, we can't really work with that. So I'm thinking for now, I'll just try to solve this using a DFS. And um, when it reaches the end, I'm just going to save the summation and return the min path. And in this problem, when it's at each node, there's only two possible neighbors, which is the bottom left and the bottom right. And so let's just use this as an example. This um, here in this case, if we're looking at node 5, the only possible neighbors are 1 and 8. And the index of node 5 is, let's see, the index of node 5 is 0, 1, 2, and it is 2. So to get the index of 1 and 5, we're going to increment this by 1 for sure. And we're going to, um, so this is 0, 1, and this is 0, 2. So I'm assuming for its neighbors, we do I plus 1, um, and then we grab um, uh, j minus 1, and j is what it seems. No, 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 no. Because if we're here, oh, sorry, this is 1. This is my mistake. So we're doing 0, 1. 1, we're doing I and okay, let's say J and J plus 1. These are the neighbors. So, or this neighbors include the first neighbor is I plus 1 and J. The second neighbor is again I plus 1, but also J plus 1. So this is are the two neighbors. Okay. Um, Now that we got that out of the way, DFS is working with um, DFS was working with not so breadth first search is first in first out. DFS is last in first out. So that is a stack. And inside the stack, we're gonna have to start with stack dot append um, the first node. And uh, because we want to find the minimum path to the bottom, we also have to store the value of um, the current sum. And so when we start at the first node, the current sum is going to be 2, where it's just the first value. And what we're doing is we're going to loop through the stack until it's empty. And so for each time in the DFS, we're basically popping the end last in, first out. And that node is here. So it's gonna be, when we pop it, it's gonna be the I, the J, and the value. Cur, there we go, her value. And so now we iterate to the neighbors. So the two neighbors, so the first neighbor, and the second neighbor. Stack append I plus 1, J, and plus. And again, also add the second neighbor, which is uh, J plus 1, J plus 1. Okay. And oh, what we have to do is check um, if I plus 1 is less than len of triangle, then we can do this. We can do this. And this one, if J plus 1 is less than len triangle, and we have to grab I plus 1. Then we can add this as well. And if else, if the neighbors don't exist, then we can keep tracker of the min path, and we know the min path. We could set the min path um, to else min path equals min path and cur. Okay, let's see. Expected. Angles not. Oh, okay. So I'm saving these as a tuple, so I need to save this as a tuple as well. Okay, so output 15. Why did it output 15? And expected 11. Um, 0, 0. Then it went to the right, 1, 1. Then it went 6 plus 7. It went right, 7, 13. It went right. Then after it reached the bottom, it made the found the new min. Then after that, it went um 3, 2. So 16, um, 16 plus 8 is 21. That's not right. Then it went to uh 2, 1. It went to 5. So 6 plus 5. Okay, so it actually reached 11, but how come it didn't actually update min path to 11? That's so weird. Oh, I returned the wrong. So stupid. I'm not sure if this will pass the time complexity. Yeah, so it's not passing the time complexity. Um, so this is a DP problem, and I need to practice DP a bit more. And so I will just end it here. But thank you for watching.